to detect and jam than traditional radar signals. So what actually happens in traditional radar is the signal is sent out and then bounces off an object, which reflects the signal back to the radar receiver. However, in quantum radar, two entangled photons are sent out instead of one signal, and when one photon hit an object, for example, one photon hits the object, the other photon instantly knows and reacts in a way that reveals information about the object location and other characteristics. So this allows for a stealthy detection of objects that might otherwise be invisible to traditional radar. So that is why a quantum radar is very much efficient over traditional classical radar system. And in military aircraft, quantum radar could be used to increase the stealth capabilities by detecting and tracking other aircraft or missiles like without being detected. So it can also be used to detect stealth aircraft or unidentified objects in the air. Like for example, if there is a missile or any rocket coming, like enemy infiltration or any invaders out there in the enemy territory, the quantum sensing and quantum radar technologies can be used efficiently to detect any incoming intruders, which can be safely avoided. And quantum radar can also be used for what I can say to detect the asteroids or comets, which is a threat to the human and to the mankind. So I guess in military aircraft and quantum radar could be used to increase the stealth capabilities by detecting and tracking aircraft or missiles without being detected. So it can also be used to detect the stealth aircraft or other objects that are designed to evade the traditional radar. However, the technology is still in the experimental stage and it might take some time to deploy in practical applications. And to tell you that quantum sensing has many kind of different applications in uh, journal applications, which are also like can be used. For example, quantum sensing can be used for medical imaging. For example, quantum sensors can be used in magnetic resonance imaging MRI to detect subtle changes in the body, human body, that may indicate the presence of diseases. And quantum sensing can be also used for mineral exploration. For example, they can use to detect the mineral deposits of natural resources is deep underground, and they can be used for GPS navigation and environmental monitoring, and they can be used for astronomical purposes as well. They can be used to detect the faint signals from other galaxies and objects in space, such as gravitational waves and dark matters and black holes. So I guess quantum computing has a huge potential. Quantum sensing has a huge potential for research and technology, and it is an ongoing area of research right now. So, like there is nothing like there are claims that quantum sensing can be used, but it is an active area of research right now. Like researchers are trying a lot to try out different things in quantum sensing, and I guess quantum sensing is also giving a new like it's making its way for different technologies as well. For example, quantum sensing is also connected with image processing, computer vision, quantum metrology. So quantum sensing is very much a new and a different field of technology which is taking place right now. So that's about quantum sensing.
But like, how many years would you think it would take before like air forces and military forces or like stealth aircraft fully embed the system into their aircraft and into their systems?
For for what kind of application?
Like, for how many years would you think it would take for like quantum radar to be fully implemented in military aircraft? Because right now you're still like in the experimental stage.
Yeah, yeah, yeah.
But like, how many years do you think it would take? Five or 10 years?
So I guess it is difficult to predict the exact timeline for the development of quantum radar for military use, because I guess it depends on various factors such as funding. So funding is very much important, and the research progress and the technological advances. So I guess all these factors, like combined factors, are will be taken into consideration to actually say how much time do we need and how much time it will take for actually getting quantum radars for the for in actual practice. So I guess it's very much important to note all of this. And there have been reports that successful demonstration of quantum radars is there in lab. Like I guess I've heard some news that actually it has been successfully implemented, but I don't know like it if it's true or not. But I have heard that some laboratories have successfully demonstrated the quantum radars in laboratory setting, and some experts predict that practical application may be possible within the next decade, like within the next 10 to 5, like next 10 to 15 years maybe. So I guess that the development of quantum radar for military use is likely to be subjected to regulatory and ethical consideration, and the technology may be subject to export controls or restriction, because you might be knowing that quantum sensing and radar technology can be misused. So it will be subjected to many much restrictions and a lot of laws and things like that. So it will be taking some time actually to implement all this. So
Okay.
yeah.
Yeah. Yeah. Yeah. Those were all the questions I had that I kind of wanted to know about like quantum sensing, and in particular, I wanted to know how it is applicable, especially to the aerospace industry. And to me itself, like it is just mind-boggling how you can, tie quantum physics and tie like quantum sensing into aerospace engineering. That itself really, I'm simply amazed by it. And yeah, I just really would like to thank you for taking the time and creating the presentation and accepting my invitation and coming on the podcast. And you have a LinkedIn page as well, which I'll link in the description of the video later when it is published. And I would just like to wish you the best with your research. And yeah, I hope to stay in touch. And yeah, thank
Yeah,
you so
sorry
much
about
for
that. My
coming.
internet
Yeah,
went off. Yeah,
yeah, no,
sorry
no,
about that.
no problem. Yeah, yeah, no
Yeah,
problem. Yeah, yeah. So yeah, thank you so much for coming, and
yeah,
I hope to see you soon.
yeah.
Mm,
On the podcast.
mm.
Yeah, hope
Yeah,
to meet you soon. Yeah.
yeah. Thank you.